Assalamualaikum and hi. Today my group going to present our WLAN design and performance improvement for CS2 buildings. So I'm NURIN QISTINA and my teammates NORADILA and RAIHAN gonna present you our findings. We use Ekahau AI Pro, a predictive Wi-Fi simulation tool, and model every access point as TP-Link AHMAD EAP725 wall. It is a wall plate and dual band AP. So for the proposed design, we move AP positions and added more of them, and then reassign channels to cut the interference.
Okay, for this project, there are four main objectives. Firstly, we identify the wireless LAN requirements for each floor, including coverage, capacity, performance, and security. Second, we design a suitable wireless network architecture by planning the access point placement, network hardware, wireless technology, and IP address scheme. Third, we propose security measures such as wireless authentication, encryption, VLAN segmentation, and firewall-based access control. And lastly, we evaluate the proposed wireless LAN design using performance indicators such as signal strength, SNR, latency, throughput, and packet loss.
This is floor 1 with the existing 7 access points. So 3 of them are clustered along this diagonal corridor, which shows that is the only solid green band on the whole floor, and 2 more sit close together in this vertical block. But when we look at the west wing, both lecture halls, the DKs, are almost entirely dark red. There's no AP anywhere near them, and this whole circular part which have the research interest group, the resource center and all, gets nothing at all. No signal strength. As for the SNR, signal to noise follows the exact same pattern. It shows strong only in the northwest corridor and the east block, where the APs are bunched together, and effectively zero across both lecture halls and the whole circular research part. This shows that only 23% of the floor clears our 25 decibel target. So all 7 access points are on the exact same channel, each labeled on every icon. It is because they are arranged in a ring around the central courtyard. Their coverage all overlap right in the middle. You see there are deep red and pink. That shows the worst co-channel interference on the floor. It fans outward through orange and yellow, then past the building of the north side, it cools down to green out at the far edges. As this, it is green as it shows the opposite reasons, as none of the 7 AP signals reach strongly enough to overlap there. For the data rate, it mirrors the coverage map almost exactly, around 65 megabits per second on average, dropping close to 0 across the lecture halls, the DK, and the circular part, and only climbing to 200 or 300 megabits right next to the 7 APs. For the throughput, after real-world Wi-Fi overhead, that becomes about 33 megabits per second on average, and inside those that zone, effectively no usable throughput at all.
Okay, next for floor 2, for signal strength, the current design shows that the Wi-Fi signal is mainly strong around the existing access points. The green areas indicate stronger signal, while the yellow areas show weaker signal. From the current design, some parts of floor 2 are covered, but the coverage is not evenly distributed. There are still areas, especially around middle and lower part of the floor plan, that receive weaker signal. This happens because the APs are more concentrated in certain areas and are not distributed enough to cover all important user areas. Next, for SNR, the current design already shows some good green areas, especially near the access points. However, some areas still have lower SNR because the signal is weaker or affected by distance and obstacles, such as walls. A high SNR means Wi-Fi signal is clearer compared to the noise or interference in the environment. Next, for floor to channel interference, the current design shows several yellow, orange, and red areas. These colors indicate that some areas experience high interference. This can happen when nearby APs use the same or overlapping channels. High channel interference can reduce network performance even when signal strength looks acceptable. And then for the data rate, the current design shows mostly green areas, meaning that the several areas can achieve good data transmission rates. However, some areas near the edge and lower part of the floor still show lower data rate. This means that the user of those locations may experience lower connection performance. And then for the throughput for the current design of floor 2, it shows that the throughput in some covered areas, but there are still yellow and orange areas where the data transmission performs weaker. This means that the current design may not provide consistent performance for all users on floor 2.
Assalamualaikum warahmatullahi wabarakatuh. My name is NORADILA. So I will present the signal strength on the current design on floor 3. Based on the simulation, the AP provide a good signal strength mainly in the area close to the AP. However, some area further away from the access point have a weaker signal coverage. This indicates that the current AP placement does not provide consistent signal strength across the entire floor. Next, SNR of the current design, most areas near the access point have a good SNR, as shown by the green areas. However, the SNR become lower in area further from the access point. A lower SNR may affect the quality of the wireless connection. So this slide shows the channel interference for the current design. You can see that some areas have a high interference, especially the orange and the red area. This is mainly caused by overlapping coverage from access point using the same or overlapping channel. Therefore, better channel allocation is needed to reduce the interference and improve the performance. Next is the data rate of the current design. Most areas have a relative good data rate as shown by the green area. However, the data rate decreased in some locations further from the access point. This shows that the current design does not provide a consistent data rate across floor 3. Lastly, this slide shows the throughput of the current design. Higher throughput can be seen in areas with a better wireless coverage, while lower throughput is found in several areas further from the access point. Overall, the results show that the current design can still be improved through the better AP placement and channel configuration.
For the redesign, we went to 11 access points. Look at the difference. There is now an AP place right in the middle of each Dewan Kuliah. So both halls shows a solid green core. And at the circular port, we place one AP dead center and it lights up the inner green. And through the research interest group office, around the rim are still orange since one AP can't quite punch through all those partition walls to reach the full ring, but it shows good coverage, nearly doubles to 37%, and the dead zone drops from 69 to 47% to 40%. So SNR shows the same lift. Both the K and the circular port now clear our targets, though the outer rings of the circular port and the far west corner still lag, but 42% of the floor now meets the 25 decibel bar up to 23. So with the new channel plan, each AP carries its own combination, both 2.4 and 5 GHz channels, like 1, 6, 8, and so on. So almost no two neighboring APs repeat the same channel. So the floor is almost entirely green now. Even that central courtyard that was deep red in the current designs fade down to just a light yellow. Co-channel interference is essentially gone. The data rate follows the same improvement. It shows average around 1 to 3 megabits per second, with the decay and the ports now sitting in the 2 to 300 range instead of near zero. And for the throughput, it comes out about 62 megabits per second on average, which roughly double the existing design. And now it is usable inside spaces that had nothing before.
Okay, then right now for the proposed design of floor 2, the signal strength becomes more balanced. The access points are placed more widely across floor 2, especially near classrooms, staff areas, corridors, and the circular area on the right side. As a result, more areas receive acceptable signal coverage. The proposed design reduces weak coverage areas and provides better overall wireless coverage compared to the current design. Next, in the proposed design for floor 2, the SNR distribution improves. More areas are covered in darker green, which means the signal quality is better. This shows that the proposed AP placement helps users receive a cleaner and more stable wireless signal. Therefore, the proposed design is better in terms of connection quality. Next, for the channel interference of floor 2, in the proposed design, the channel interference is slightly improved because the APs are distributed more systematically. However, there are still some orange and red areas, especially around the central left part of the floor. This means that although the proposed design improves coverage, the channel plan still needs further optimization. Next, for the proposed design of floor 2, the data rate is more consistent across the floor. Most of the important indoor areas are covered in green, which indicates better potential speed and better wireless performance. This improvement is caused by better AP placement and wider coverage distribution. And lastly, for the throughput of the proposed design of floor 2, it improves because more areas become green. This shows that the proposed wireless LAN design can support better data transmission performance in the main usage areas. Users in classrooms, staff rooms, labs, and corridors are more likely to experience stable network performance.
For the proposed design, the access point were repositioned and additional access points were added to improve the wireless coverage. As shown in the simulation, the signal is now distributed more evenly across floor 3. This provides better coverage in target area and reduces the area with weak signal compared to the current design. For SNR, the proposed design shows good SNR across most area of floor 3 as indicated by the green area. The improved AP placement provides a better signal quality throughout the floor. This allows users to have more stable and reliable wireless connection compared to the current design. For the channel interference, different channels were assigned to the access point in the proposed design instead of using same channel for all APs. As a result, most areas show lower channel interference as indicated by the green and yellow area. This channel optimized help reduce interference between nearby access points and improve overall performance. Next, the proposed design shows an improvement in data rate across floor 3. Most of the target area are covered by green region, indicate a higher data rate. The improved AP placement and channel configuration provide better wireless connectivity and allow users to achieve more consistent data rate. Lastly, the throughput results show that the proposed design provides better performance across the most area of floor 3. The green area indicate higher throughput, especially in the main coverage area. Overall, the improved AP placement and channel configuration provide more consistent network performance compared to the current design. To conclude, the proposed design improves wireless coverage and overall network performance through better access point placement and channel configuration. This also helps to reduce channel interference. For further improvement, centralized monitoring is recommended to make the YLAN easier to manage. Regular network monitoring and site surveys should also be conducted to identify performance issues and ensure that the YLAN continue to meet a future user requirement. Thank you. That's all from us.